I'll just say paper 1, mathematics. But this is grade 10. So our focus is going to be mainly the June exams. Okay. Now we're going to look at the breakdown of what is exactly expected of us. And then we can look at some few questions or sample questions on how they can be answered. So usually paper 1 of grade 10 in June is just a paper out of 50 marks. Usually maximum is 50 marks or minimum is 50 marks. Okay, and it's usually written for a duration of 1 hour. So under these 50 marks, the topics are not that much because remember the coverage is the content of term 1 as well as term 2. And since that content needs to be broken down into paper 1 and paper 2, so it's just a few questions that could be brought about in paper number 1. All right. Okay, so usually the first topic or the first question will have what we call the algebra. Algebra as a topic is very wide, okay? So under this, the first part they normally want, most cases, is sometimes you can ask about the types of numbers, okay? In other words, we just call it the number system, how the number system works. Remember, under this, we have what we call the natural numbers, the whole numbers. We also have what we call the integers, but in grade 10, we are more interested in what we call the rational numbers, as well as the irrational numbers, okay? Then how we represent these numbers and what constitutes them. Because still under rational, you could be asked to write a number, let's say 0.45. Write this as a common fraction. Or they can give you something that is recurring, and then they ask you to write this or express this or show that this number is indeed rational. Because remember we said a number can be rational if it can be expressed in the form of A over B or A over C with a numerator as well as a denominator. Then the next part that can be expected under algebra is what we call the exponents. Okay, under this we need to remember the laws, the different laws of exponents. Law number 1, when you're multiplying numbers with the same bases, what happens to the exponents? We said you just add them. When you're dividing numbers of the same bases, what happens to the exponents? We just subtract them. Then if we have an exponent to the power of another exponent, we just multiply those two exponents. Okay. And lastly, if you have something, the exponent of 0 is 1. You have a to the negative m. This is the same as 1 over a to the m. So these are basically the typical laws that they normally ask about, okay? And then what they also like about this is how do people prime factorize numbers, okay? If you're given, let's say 27, are you in position to express this 27 as an exponential number or an exponential format so that it is 3 to the 3? If you're given maybe 64, we know this is a unique number because it can be expressed in different formats. So one can say this is the same as 2 to the exponent of 6. Or someone can say it's 4 to the exponent of 3. So whichever way, but we always prefer at least the base to be a prime number, okay? So we can look at exponents and the laws under the first part of the paper. And then the other part they also like about this is the factorization. Okay, we can say factors or factorization because I'm going to also add what we call the products. Okay, factorization and the products because these go hand in hand. So with the products, like if you have two brackets, a binomial and maybe we have a trinomial. Let me just use reasonable expressions, maybe 2x plus y. And then here you have x squared plus maybe 2xy minus a y squared, something like this. how do we open this up? Okay, we can have x minus 1. In most cases, they will never ask you this, but it's possible. And then something of the sort. Then open it up. How do we work around this? So these are products. Okay, and then how we move from the normal expressions. Let's say we have x squared plus 7x plus 12. For us to move from this format back to this format of the products, that is what we call factorization. And moving from the products to this format, that's what we call the products. Okay. Now, remember with factorization, we have the different methods. One, we have what we call the common factors. An example, if you have x cubed plus 3x, and then they want us to take out what is common or to factorize. So we can see there's x. When you take that x out, you'll have left x squared plus a 3, and then that is done. So this is straightforward, okay? And it's the first method of factorization. Then 2, we have what we call the difference of two squares, whereby if I have x squared minus y squared, this must give us x minus y and then x plus y. In other words, you have to get the square root of the first term and then the square root of the second term, and then express the answers with brackets that have the same contents but different signs. Okay, it doesn't matter which sign comes first. The plus can come first, then the minus, and so on and so forth. Then number 3, we have what we call the grouping. Let me say we have this, and then is it gonna make sense? Let me call this for xy and then 6y. This is not gonna make sense. All right, so if I have something of this nature, what can I do? Now let me just change this and make it maybe 8 and see if this is gonna help me. Is it gonna make sense? Is it gonna make sense if I make this a 6y? All right, let me see. So if I combine this and then I combine that, so I'll have 8x plus 6y plus a 3y plus 4xy. And then I can take out what is common in that case. Okay, so just do the grouping, or you can do it any other way. You can always end up with the same result. So what is common here? You can see if I take out, well, that's not going to help me. That is not going to help me, unless if I make this a squared. That makes some bit of sense. Let's see. So if I make that a squared and take out what is common, which is a 2, I'll be left with 4x plus 3y. When I look at this, there's nothing common except the y, so I'll take out the y. I'll have 3y plus a 4x. And then take out this bracket again, so I'll be left with 3y plus 4x into 2 plus a y. So that would be the grouping part of it. And then number 4, we have what we call the trinomials. Okay, so these trinomials work around what we call the product as well as the sum. Okay, so if we have a quadratic expression of ax squared plus bx plus c, we know that a and c will represent our product, and then the sum will be represented using the b. So if I have just a plain simple example of x squared plus 7x plus 12. So usually aim at making the a 1, okay? But there are cases where a cannot be made a 1, okay? So let's look at this. So if we have just the one, this is going to be 1 times 12. So our product is 12. And then our sum is going to be this 7 here. So then we look for two numbers that we multiply to give us 12. So you can have 1 times 12, 2 by 6, 3 by 4. Since the product is positive, which means we can have also negative factors. Negative 2 times negative 6, negative 3 times negative 4. And then from all these factors, which pair is going to give us a sum of 7? So this pair, this is the only pair that gives us a sum of 7, but also gives us the product of 12. So get that pair, open your brackets. You have x plus 3 and then x plus 4, and then that becomes your answer. Okay, now we have cases where we just have something like that. I don't know if this will make sense. Okay, we can have a scenario of this nature, and then they ask you to factorize. Let me try and see if really there are factors here. So the question will be, how do I obtain this 2x? It's a 2 and then the x. And then how do we obtain a 5? It's just a 5 times 1. Okay, and then we just try to play around with the signs and see. So since the middle part is positive, if I put here plus and put here minus, if I open this and that, that's going to give me negative 2x. If I multiply this and this, is going to give me a positive 5x, which if I simplify that, because these are like terms, I'll be able to get my positive 3x, which means this combination is correct, and that will be our answer. So this method where the a is not a 1 is just a try and error. Okay, look for terms that you multiply with the first term, express them in both brackets, and then look at the last term. Numbers you multiply to give you a 5, keep on switching them around, play around with the signs up until you get the correct part. All right, then in grade 10, you also visited something to do with the cubes. Okay, an example, we can talk about the sum of 2 cubes. That's going to be maybe x cubed plus y cubed. How do we factorize this? So we shall have x plus y into x squared minus xy plus y squared. Let's try to open this and see if it's going to give us what we need. So that is x cubed, that is minus x squared y, that is xy squared, then this is xy. So this and this is going to be x squared y. And then this and this is going to be minus xy squared. And then we have our y cubed. So this cancels that. This cancels that. And then we shall be left with a positive. So that is correct. So this is how we express the sum. And then the difference, let's say x cubed minus y cubed. So this can be factorized as just x minus y into x squared plus xy and then plus y squared. So you just express them in this format. So let's have a scenario, okay, where I have maybe 8x cubed minus, let me just use 1, because we know that 1 cubed is still a 1. Okay, so step number 1, I'll find the cube root of the first term, which is 2x. Put the minus sign, the cube root of 1 is 1. Then for me to get what is left in the bracket, I'll square this. So 2x squared will give me 4x squared. And then I'll use my plus sign. I'll multiply this and that. 2x times 1, I'll get a 2x. And then I'll square the last part. So 1 squared gives me a positive 1. So that becomes my answer. Same applies with a plus. If I have 64 plus maybe a cubed, the cube root of 64 is going to be a 4. And then I'll say plus a. And then 4 squared, that is 16, minus 4 times a, that is 4a, and then a squared, I'll get a squared. And then this becomes my result. So guys, those are the different methods of factorization. And in grade 10, unfortunately, we expect you to at least remember and know all of them, because it's just the cubes that were introduced this year. These others were seen right from grade 9. Okay, so that is to do with the first question. Then under the same thing, or under the same aspect, we can expect something to do with equations. Okay, under these equations, we have different types. We have what we call the linear equations. These are straightforward. Okay, they give you 2x probably into, this is not going to make sense, it's not going to make sense. Let me erase this out. So 2x plus a 4 must give us a 14. In grade 10, they can never ask you such a direct question because we know that your level of thinking has kind of advanced. So we can just give you something like this. Or we can say 2 into x plus a 4 is equal to 7 into 4 minus x, something of the sort. And then we expect you to know how to work out this. Remember, the aim is to isolate the x. Leave x on one side, leave all the numbers on the other side. And then also remember that when you're transposing, when you're moving, let's say this 4 to the other side, this 4 is positive. When it crosses the equal signs, it must become negative. So if we are adding and then we carry out a transposition, we must use the inverse, which is minus. If we are subtracting, we apply the addition. Then same applies with multiplication. We shall divide and then we shall multiply. So these are the scenarios that we need to look into when you're solving linear equations. Then 2, we have what we call the quadratic equations. Okay, that's where they will tell you x squared maybe plus 3x plus 4 is equal to 0. Now, many times learners confuse or they tend not to know when to solve an equation and when to just factorize and stuff like that. When they ask you to factorize, just find the factors and stop there. When you see equal signs with a 0, then they want you to solve, find the real values. So we know that with a quadratic, we expect you to have 2 answers. Okay, so if we use our factors, our product is 4, and then our sum is 3. The 2 numbers that we look at, is this even going to make sense? No, it's not going to make sense. Let me change this to a 4, and then I also change this to a 3. Then it will make more sense. Okay, so our product is a 3, and then the sum is a 4. So the 2 numbers are just 1 and 3. It's going to be x plus 1 and then x plus 3. This must give us a 0. Okay, then just get the whatever is inside the brackets and equate it to 0. Or x plus 3 is equal to 0. So the first solution will be -1, and then the second solution will be -3. So those will be the solutions for the quadratic equations. Okay, so remember we have different methods of solving or factorizing. So even questions can come in that manner. So linear equations, we expect just one answer. Okay, and then quadratic, we expect 2 answers. And then the other aspect under equations is what we call the exponential equations. Okay, these are equations that have exponents in them. So one rule that we need to remember is that for as long as the bases are the same, okay, which means even the exponents are automatically going to be the same. Or if the exponents are the same, then the bases will automatically be equal to each other. That's how we solve the exponential equation. So the aim is for learners to know how to break down the numbers. Okay, if you're given 81, are you in position to change this 81 into an exponential form? Okay, it can be a 9 squared, or it can be a 3 to the exponent of 4. This can be done right from your calculator, or you can just break it down using the prime factorization. And then lastly, we have, no, not lastly, we have the simultaneous equations. Okay, simultaneous equations, you have 2 equations with 2 unknowns. Okay, and then you have to find these unknowns. So at school, you might have seen two methods of working this out, okay? We have what we call the elimination, where you get rid of something, get rid of one variable so that you can just work with one. And then after getting that one variable, you go back and replace and find the other or the second variable. So one method is elimination, and then the other is called substitution. Okay, we shall go over all of these when we are looking at our sample questions. And then lastly, we have what we call the inequalities. Okay, inequalities, that's where we have our inequality symbols of greater or equal to, less or equal to, and then we can even have just greater or less. We just need to know the principles that work around with these inequalities, especially let's say when you're dividing or multiplying with a negative sign, a lot will be affected. And also remember how to represent numbers on a number line after solving the inequality. All right, so I think I've said a lot about the first part of paper 1, okay? Because there is also another part, or the last topic for June, that we should expect, and that is going to be the functions. Okay, functions, sometimes we just call them the graphs. So previously in grade 9, we used to just look at functions as y is equal to 2x plus 1, y is equal to 4x minus 6, and so on and so forth. In grade 10, we introduce what we call a notation. A notation is just a format under which something is represented. So instead of us using y, we prefer to use the function of something, okay? F of x, function of x, is given as 2x plus 1. Function of y, now it can never be y, just x, okay? Now, this x represents our input, okay? It does not only mean that we're going to deal with just f. It can also be a g. G of x is equal to maybe 2x plus 1. It can be h of x is maybe 4x minus 6. It can be m of x, any letter of x. It just simply means this h of x, g of x, they all represent the y. Okay? Now, if we ask you to determine f of 1, in others, now we are replacing x with a 1. So you must do the same thing here. It's going to be 2 times 1 plus 1. And then you get your y value as a 3. If we ask you for the f of negative 6, when you're dealing with this, okay, where there is x, now we are replacing with a negative 6. So it's 4 times negative 6, and then minus 6, which gives us a negative 30. Okay, so that is what we will do with the function notation. So under the graphs in grade 10, I normally look at number 1 is the straight line. Okay, we call them line graphs. So what we need to know is how do we get the equation of a line graph? It's mx plus c. Okay, this is the general equation. What is m? M is the gradient. And how do we find the gradient? We normally say the change in y over change in x. Or in other words, we can say y2 minus y1 over x2 minus x1. For us to find the y-intercept, you just have to replace this gradient into the formula and get a point where the line is passing and then get the value of c. So we use this format, or we can use y minus y1 is equal to m into x minus x1 as another approach to finding the gradient of a line. What we need to remember is the shape of a line is just something like that. Okay. Now, if we have lines that are parallel, okay, these are basically lines that will never meet. So it simply means that the gradients are going to be the same. Gradient of 1 is the same as the gradient of 2. And then if we end up with lines that are perpendicular, these are lines that are meeting at 90 degrees. In other words, they are intersecting at 90 degrees. So what happens with this is that the gradient of 1 times the gradient of 2 must give us a negative 1. Now, we also have horizontal lines, okay? Lines that are just lying in that format. For as long as it is parallel to the x-axis, the gradient is going to be 0, which means that their equations will be just y is equal to a certain number. We also have the vertical lines that are parallel to the y-axis. So these ones, the gradient is undefined. In other words, it doesn't exist. So their equations will be x is equal to a certain number. So we just need to remember about the line graphs. Then the second function that we look at, or the second graph, is what we call the parabola. Okay, parabola is the first time grade 10s are looking at it. This is also known as the quadratic function. Quadratic function or the quadratic graph. So the general equation in grade 10 is ax squared plus q. Okay, the shape of a parabola will be a smile or it will be a frown. Okay, we only get a smile if our a is positive. We get a frown if our a is negative. Okay, now this q represents the y-intercept of the graph. So in other words, if we have a Cartesian of x and y, we expect the graph to be either in this format or it could be drawn in this sort of format. So that is how the parabolas are going to look like. Now, what we need to look for when you're talking about a parabola is the turning points. How do we get the turning points? So we said Q is one of them, and your turning points are always going to be on the y-axis. Okay, so which means x will be always a 0, and then Q will be the y value. Okay, next we have what we call the axis of symmetry. Axis of symmetry, that is the line where the parabola is being divided into two. So in this case, we're going to say x is equal to 0. Okay, and then what else? We need what we call the domain. Okay, I'll start with the domain. So when you ask for domain, these are x values. Okay, and the domain of a parabola, x will always be an element of real numbers. Now, range. Okay, the range represents the y values. Those are y values. Now, these y values depend on the turning point, or they depend on the q value. So if this q is on a graph that is having a smile, okay, so which means our y must be greater or equal to q. That is if it's a smile. And then if the q is on a graph that is having a frown, then y must be less or equal to q, if that is our frown face. So that is to do with the parabolas. There is nothing much, okay? Then the next graph is what we call the hyperbolas. Okay, hyperbola. So first time for grade 10 to hear such a term. So hyperbolas are unique in that they have what we call asymptotes. So an asymptote is basically a line or a point where the graph will never cut. Okay, so I have two scenarios. The first scenario, if I have this as my horizontal asymptote, I expect my graph to be either here or basically here. This is scenario number one. If I keep the same asymptote, okay, I'll expect my graph to be here or to be somewhere here. So this is the shape of the hyperbolas. So what is the general equation of a hyperbola? It's usually given as, I don't want to use y, okay? Let me just say f of x is equal to a over x plus a q. Or we can have, let me call this a negative to represent that function, or a over x plus just a q. Okay, so if a is negative, we expect the hyperbola to look like this. If a is positive, we expect the hyperbola to be in quadrant 1 and quadrant 3. Quadrant 2 and 4 for the negative. Now, when they ask for asymptotes, remember we say these are points where the graph is not going to cut. We have two asymptotes. So the first one is normally given as x is equal to 0. So this line of the y-axis is an asymptote in grade 10. Okay, the graph will never cut that line. Same story here. Okay, And then the second asymptote is what we call the horizontal, which is this one. So the graph can never cut that line there. And then this Q represents that asymptote. Okay. So X is equal to 0 or Y is equal to Q. Q and A, those will be just numbers there. This one is just a constant. It will always be X is equal to 0 unless there is a transformation or a shift of the graph. The last part is what we call the axis of symmetry. Okay, that's when the graph is divided into two parts. So we have two equations. Okay, Y is equal to X plus C, or Y is equal to negative X plus C. So what C is depends on the value of Q. So if Q is a 3, then C becomes a 3. If Q is a negative, then even C becomes a negative. So they will give you a scenario, and we shall only expect you to give us the equation of just one graph. Okay, so that is to do with a hyperbola. And then lastly, we have what we call an exponential graph. Okay, exponential graph. So the general form, I'll use g of x is equal to a to the x plus a q. So still this q represents an asymptote. Okay, that's an asymptote. Now, if a is greater than 1, then the graph is increasing. Okay, but then if a is between 0 and 1, which means it's a fraction, then the graph will be decreasing. So this will be the shape. So you just have to pay attention to the shape and what exactly happens. Okay, whatever happens next, you have to know at least how to sketch, because we in written we always test on sketching. So how do we sketch graphs? So for you to sketch a graph, number one, you need to know the correct shape. Then 2, you need to know about the intercepts. Intercepts, these are points where the graph is cutting the axis. Okay, an example for x-intercept, y will already be a 0. And then for y-intercept, okay, x will always be a 0. So just remember this when you're determining the intercepts. So what we mark, the shape, and then the intercepts. So that is that, guys. So let's look at our sample questions that we have prepared. All right, so we have question number 1. Okay, question number 1 is asking us to simplify. We have 5x plus 1 into this. So as long as just simplifying 2 brackets, you just have to open them up, or we have to expand the brackets. So use your dots. So I'll say 5x into 2x squared minus 3x minus 1. And then plus 1 into 2x squared minus 3x minus 1. So same bracket. So everything here must affect everything that side. I'll open this up. It's going to be 10x cubed minus 15x squared minus 5x. Open here. I'll have 2x squared minus 3x minus 1. I'll then collect the like terms. Okay. So 10 cubed is on its own. So I'll leave it there. And then this and this are together since they have x squared and x squared. So negative 15 plus 2 will give me negative 13x squared. Negative 5 minus 3, that's going to be negative 8, and then minus 1. So we don't have any like terms left here. And then that becomes our answer. All right. Question number 2, 9 to the x plus 1 times, the dots represent multiplication. 5 to the x plus 2 over 45 x to the 1. Now, what I can see is that 5 is a simplified base. 45 isn't. So either way, I can choose to simplify all of that. So I'm not going to break down the 9. I'll keep it. 9 plus 1 multiplied by 5x plus 2 over, I know that 45 is the same as 9 times 5. So I'll say 9 times 5, everything is to the exponent of x plus 1. Okay, then I need to split that up. So 9x plus 1 multiplied by 5x plus 2 over 9x plus 1 multiplied by 5x plus 1. These are the same, which means they can just cancel out. Even if I apply the laws, I'll get 0, exponent 0. And then here, I'm seeing x plus 2, seeing x plus 1. Then I'll subtract. I apply law number 2 where you subtract numbers with the same bases that are being divided. Oh, I can split this. I have 5 to the x, 5 to the 2, 5 to the x, 5 to the 1. So this cancels that. And then my answer is just a 5. Or you can do the subtraction. You'll still get the same thing. Then 1.2, they want us to factorize. I've already seen this question. We've already used this as an example. Okay, no problem. So 2 brackets, how do we get 2x squared? I can multiply 2x by x. I have my 2x squared. How do I get 5? I can get 5 times 1. So I can put a 5 here, and then I put a 1 here. If you don't know where to put it, you can still try the 1 there and the 5 there. If you try to open it up, it doesn't make sense, you switch. Then the signs, I'm having a positive 3. So I will put my positive here next to the big number. I'll put a negative there. So I give you a mark there and then a mark there. Okay, don't expect a lot of marks for this. Then 1.2.2, it's quite a big question. Let's see what we can do here. How many terms are there? 1, 2, 3, and 4. Okay, there are 4 terms, which means we can do the grouping. We can do the grouping, but let me first simplify the exponents. So that's going to be negative 3 into a negative and negative. That's going to give me a positive 9. X, this 2 multiplies with a 4. That's going to be 8. And then y squared. And then minus a negative 3 cubed. That's going to be negative 27. X to the 6. Y to the 6. Okay, these are just the same things. 12y to the 4. Simplify this further. I'll have negative 27 x to the 8 y squared. This and this will give me plus 27 x6 y6 plus 12x squared minus 12y to the 4. Then what I'll do next is I'll try to group this since there are 4 terms. Remember, grouping works only with 4 terms and beyond. So what's common there? I can see a 27. I take out the smallest x, which is x to the 6. The smallest y is y squared. What do I have left? I have a negative x squared. Okay. And then here I'll be left with a positive y to the 4. When I look at this, what's common is the 12. I'll be left with x squared minus y to the 4. Okay. Now, I can see that there's a bracket that seems to be the same. Okay, this bracket here looks more or less the same as that. So for me to create similarity, I have to take out a sign. In other words, I can introduce a negative sign here. If I make this a negative, then everything here will switch signs. So now the brackets are looking the same, but with the introduction of negative. Then take out this bracket. So I'll have, let me rewrite it as y4 minus x squared into this and this. I have 27 x6y squared minus 12. Okay, minus 12. So what I'm going to do, I can still see that there are things that are common. This is a difference of 2 squares, which means I need to break it further again. That's why the question is 6 marks. So that's going to be y minus x. It's going to be y squared minus x. And then y squared plus x. This is 27. This is, that is what? That is 12. You can take out a 3. Okay. If I introduce a 3 there, that's going to be 9x to the 6 y squared minus 4. Still, this is a difference of two squares. I need to break that down again. Y squared minus x, y squared plus x. Square root of 9 is 3. Then divide this by 2, which is a 3y. Minus square root of that is a 2. And then 3x cubed y plus a 2. So this must be our final answer for 6 marks. Beautiful. So we have difference of two squares there. We have vectors involved, the change of sign, and then the grouping. It's a mixed masala question. All right, so that is question number 1. Question number 2, they want us to solve for x. Okay, so whenever we have brackets, open the brackets up. So I'll jot it this side. X into x minus 4 is equal to 12. Okay, we're saying x into x minus 4 is equal to 12. So step number 1, we open it up. It's going to be x squared minus 4x is equal to 12. Let's move the 12 to that side. It's x squared minus 4x minus 12 is equal to 0. We can now look for our factors. Product is negative 12. And then the sum is negative 4. Two numbers that I'm seeing will be 6 and 2. I'll put that I said 6 and 2, not 6 and 6. That's a negative and this is a plus. Okay, so which means x is a negative 2, so x must be a positive 6. That is 2.1. Then 2.1.2, we have fractions. We have fractions, okay? So x minus 3, I'll put it this side. We have x minus 3 over 1 minus x squared. Okay, minus 2x plus 4 over x plus 1. Okay, this is equal to minus 2x over x minus 1. So that is the question. Now they want us to multiply or to simplify this. Now what I normally do is that as long as we have denominators, let's try to get rid of the denominators and find the LCD and then we take it from there. So I know that this is x plus 1, x minus 1, which is a difference of two squares, which is more or less the same as this. Just that now this one's going to give us x squared minus 1. So I'll do the same thing. I'll multiply through by x squared minus 1 and we see. So x squared minus 1 multiplied by x squared minus 1 multiplied by x squared minus 1. So with this is 1 minus x squared, so which means there's going to be a negative sign to be introduced so that it becomes x squared minus 1. So I'm transferring that negative just to the top there so that I don't forget it. Okay, now this, remember x squared minus 1 is the same as x minus 1 and then x plus 1. So this plus 1 cancels the plus 1. I'll be left with just the minus part of it. Okay, then here the negative is going to cancel the negative and I'll be left with just the plus part of it. Then I'll have just everything under one line. Okay, open that up. So negative x plus 3. Then I can put this in brackets as well. Can open it. No problem. 2x and that is going to be 2x squared. That is minus 2x. And then this is plus 4x. And then that's a minus 4 is equal to, you can open this, negative 2x squared minus 2x. Open this bracket up again, negative x plus 3 minus 2x squared. I know that this and this is going to give me a plus 2x because these are like terms. Then I introduce the negative, becomes negative 2x. Negative and negative, I get a plus 4 is equal to negative 2x minus 2x. All right, so it's a party time where we collect the like terms. Since I'm having a negative 2x squared and a negative 2x squared, this will cancel that. Okay, and then I'm having a negative 2x and a negative 2x. This will also cancel that. I mean, they are the same, but on the opposite sides of the equal signs. Then I have negative x plus 7 is equal to 0. I can move the negative x that side. So 7 is the same as x. Therefore, our x is a 7. Should be 4 marks, this question. How many marks are they giving us? It's just 3 marks. All right, no problem. Still, no. It's 5 marks. It's 5 marks. Yeah, people are generous this time. All right, 2.1.3 is the exponential. So we have 2 to the x. 2 to the x, okay. Minus an exponential equation, this one. 2 to the x minus 1. Okay, this is equal to 4. So step number 1, split this up because we need to do the factorization of the 2x. So wherever we have exponential equations and there's a minus or plus between them, it's going to be factorization. So from our laws of exponents, that will be 2 to the negative 1 is equal to 4. The first law. Because if we add up this, we must go back there. So take out the 2 to the x. We'll be left with 1 minus. We know that 2 to the negative 1 is just a half. This gives us 4. What is 1 minus a half? It's a half. Okay. It's equal to 4. Then divide both sides by a half. Divide by a half. That cancels that. 2 to the x becomes 8. Then break down 8 or express 8 in the form of 2. So that is 2 to the x is equal to 2 to the 3. Bases are the same, which means the exponents must also be the same. So that will be the answer to that question. Then 2.2, this is an inequality. They want us to solve for x. Now in this case, we need to aim at leaving x in the center there. Okay, so what's going to be the first step? Let's eliminate this one. Move the one that side, move the one that side. What you do to the left must be also to the right. What you do to the left must be done to the left, to the right as well. Okay, so we have negative 2 is less. We have negative 2x minus 1. And then is also less 3. Is an equal sign here. Okay, so move it there, it's or just a plus sign. So negative 2 plus 1 is less or equal to negative 2x is less 3 plus 1. When you carry over, it's just the same transposition sign. Then it's going to be a negative 1 is less or equal to negative 2x is less 4. Then when you divide through by negative 2 every way, this will cancel that. So that we have our x. But dividing inequalities with a negative must change the signs. If it was less than, it can sound greater than. So even that must change. So 4 divided by negative 2 will give me negative 2. Then this is negative 1 divided by negative 2 will just give me a half. Then we can rewrite this as a negative 2 is less x less or equal to a half. So that becomes our solution. Okay, what's the next question asking for? Rewrite your answer using the interval notation. So that is the interval notation. Illustrate the answer on a number line. So we're saying x is an element. Okay, we say negative 2 and a half. Something like that. So if you are to draw a number line, it will be just a line there. We say negative 2, and then this is a half. Okay, the equal sign is by a half, which means if we are drawing our dot, it must be closed by a half, and then by negative 2, it must be open. And then you connect that. So that is our number line. All right, 2.3. The sum of 2 square consecutive numbers. The sum of the squares of 2 consecutive natural numbers is 85. Determine the numbers. What are we going to do here? Let's see. The sum of squares of two consecutive natural numbers. Okay. Let the first number. Okay, I'll let my first number be any letter. I'll use x. Which means that the second number or the second number is going to be x plus 1 because natural numbers increase by 1. Money? So if this is x, this must be x plus 1. But they are telling us if we get the sum of the squares, so it's going to be x squared plus x plus 1 squared must give us 85. What are the numbers? Open this up. So it's x squared plus, that's going to be x squared plus 2x plus 1. Use the FOIL method is equal to 85. And bring everything to one side so that I can solve my quadratic. So that's going to be 2x squared plus another 2x. When this one comes that side, it's going to be negative 84. Gives me a 0. And then what I do next, I divide through by 2 to make life easy for myself. So it's x squared plus x minus, that's going to be a 42 is equal to 0. So which two numbers do I multiply to give me negative 42? When I add them, I get 1. I know it's going to be 6 and 7. But since my product is a negative, I'll make this a negative. Okay. It's going to be x minus 6 or x plus 7 is equal to 0. Solving this, x is going to be 6 or x is going to be negative 7. Remember, x is the first natural number of interest here. Okay? So, we can test it and see. Because if x is a 6, which means the next number is going to be a 7. Because it will be 6 plus 1, which is a 7. I'm going to reject the negative 7 because negative 7 is not a natural number. Okay, so no solution is not applicable. If I get 6 squared plus 7 squared, so 6 squared is a 36, then 7 squared is a 49. When we add that up, you get your 85. Question answered. We move on. Question 3, I'm not working it out. This is for term number 4, number patterns. I'm looking at the last question, which is the functions. Sketched below are the graphs of f of x, 2x minus 4. So this is a straight line. And then g of x is ax squared minus q. We say this is a parabola. And then h of x is mx plus c. This is also a line. A and B are the intercepts of x, C is the turning point, B is the x-intercept of C, and so on and so forth. All right. They want us to determine the equation of G for 3 marks. So the question is, what is G? G is the parabola. But we know that this parabola is turning at this point. Which point is the y-intercept of f? So from this straight line, we know that negative 4 is the y-intercept. So this C is a negative 4. Okay, that's a negative 4. So we already have our Q as a negative 4. What we need is the A. Okay, and how are we going to get the A? We can start by finding the values of B. So we know that along the x-axis, y is a 0. So using f, using the equation of f of x, we're going to say if y is a 0, we have 2x minus 4. I can move the 4 that side, so 4 is equal to x. Then divide both sides by 2, which means x is a 2. So this becomes a 2. So the coordinates there will be 2 and 0. Then if I try to write out the equation of G, it's going to be ax squared minus a 4. Then for me to get the A, I can use this point. Where there is x, I put a 2. Where there is a y, I put a 0. So 0 is equal to A into 2 squared minus 4. And move the 4 that side so that I have 4a. Divide both sides by 4, which means a is 1. Therefore, the equation becomes x squared minus 4. and then that is the function that we need. Okay. Then they want us to show that h is given as this. If the length of CD from here up to here is 5 units. So since this is negative, it simply means that from the origin up to here, those are the 4 units. So which means this is going to be just the 1 unit of interest to make it 5 units. So the coordinates of D therefore will be 0 and 1. Okay. The coordinates of A are going to just be negative 2 and 0, since this graph is divided into 2. If this is a 2, this is a negative 2. If this is a 4, that is going to be a negative 4. So we have 2 points, and we can get that equation. So equation of a straight line, we need the gradient. Okay, I'm going to say the gradient of AD is change in y over change in h. So I'm going to say 1 minus 0. So this is my x1, y1. This is my x2, y2. So I'm saying y1 minus y2 over x1, which is a 0, minus x2. This is minus 2. That gives me a half. But I already know that the graph is cutting the point 1, which means the equation is just going to be a half x plus 1. So we're going to give you marks for identifying the correct coordinates of D. We're going to give you marks for finding the gradient and rewriting the equation. That is 4.2. And then determine the coordinates of E. Where is E? E is where the two graphs are meeting. Now, for us to get equations where graphs are meeting, it simply means that at point E, the two graphs are equal to each other. In other words, we're solving this simultaneously. So we have this, and then we have the 2x minus, they said what? Minus 4. So if y is 2x minus 4, and then y is also a half x plus 1, equate the two equations together. Equate the two equations to each other. So let me just use a different pen there. Okay. So I'll say 2x minus 4 will be the same as a half x plus 1. Move the 4 this side, move the half that side. So 2x minus a half, that's going to give me 3 over 2x is equal to 5. Multiply or divide through by 3 over 5. Sorry, 3 over 2 over 3 over 2. Then which means my x is 10 over 3. Then for me to get the y coordinate, I'll get this and either substitute it into this or substitute it into this equation for me to get my y value. Let's see if I did the correct thing, guys. 2x in a subtract, I get 3x over. Perfect. Okay, so which means my y is going to be a half multiplied by 10 over 3 plus 1. That's going to be 10 over 6 plus 1, which is the same as 16 over 6, which is 8 over, by 2 is a 3, by 2 is 8, yes, 8 over 3. So we have 10 over 3 and then 8 over 3. So these are the coordinates of G. Then range of G, what is G? G is the parabola. So we said y must be greater or equal to negative 4, since this is a smiling parabola. And then for which values of x is f of x greater? So we only find f greater than, they said what? G of x. At this point, where is the graph of f on top? So the graph of f is above G, just between these points. That's when this graph is above. This one is below. After that, this graph is above, this graph is above. So they want the x value. So between 0 and positive 2. So how do you write that? Just going to say 0 less or equal to x less or equal to 2, since we have an equal sign there. So guys, that is that with paper 1 preparation. I wish you guys all the best. Please prepare, revise, and do your best. Okay, so let's meet again when we are looking at the solutions to some of the papers that you guys would have written in your various schools, various provinces, as well as the various districts. Okay, guys, go make us proud. We believe in you. We trust you guys. Just make us proud. Thank you very much and all the best.